AI tools are already part of many developers' daily work. They show up in editors, in code review tools, and in documentation workflows. And for a lot of us, they have quietly become something we reach for without thinking too much about it. At the same time, there's a growing gap between what people expect these tools to do and what they reliably do today. This video is about narrowing that gap, not by talking about what AI might do someday or by repeating product demos, but by looking calmly at what it can and cannot do for developers right now. Being clear about that turns out to be surprisingly useful. It saves time, reduces frustration, and helps avoid building systems on assumptions that don't hold up once real users and real constraints show up. When developers talk about AI today, they are usually talking about large language models, primarily. Tools that generate text, including code, by recognizing the patterns in large datasets. They don't understand your product, your users, or your business goal. They generate outputs that look reasonable and often are useful, but they don't come with any built-in guarantee of correctness. That distinction is subtle, but it matters a lot in practice. A common assumption is that AI understands your codebase. In reality, it only sees the fragments you give it, and it treats them as text, not as a living system with history and intent. Another common belief is that AI can replace planning or architectural thinking. It can suggest patterns, sometimes very good ones, but it can tell which trade-offs matter most in your specific situation. And there is also that quiet assumption that if code compiles, it must be right. Anyone who has maintained a production system for a while knows how misleading that can be. Compilation tells you very little about whether the code actually behaves the way your system needs it to. A lot of the hype around AI comes from how it is presented. Demos tend to focus on best case scenarios, small scripts, clean inputs, and problems that are already well understood. What you don't see as often is the cost that shows up later, when generated code has subtle bugs or when someone has to reason about logic that was written without real context. Those costs are rarely dramatic, but they add up quietly over time. Talk about AWS, for example. So, where does AI genuinely work well? It's extremely good at transforming text, pretty much. Things like summarizing code, rewriting functions for clarity, renaming variables, or explaining familiar syntax. It's also strong at pattern completion, which is why it's so useful for boilerplates, scaffolding, CRUD operations, or drafting test structures. And it's quite helpful during early thinking when you're exploring options, comparing approaches, or trying to get unstuck, at least on my experience. These are all assistive tasks. They reduce effort and speed you up, but they don't replace judgment per se. In real software projects, AI tends to work best when feedback is cheap. If you can run the code quickly, test it easily, or throw it away without much risk, it is a great accelerator. It shortens the distance to a first draft. It's also valuable when you're working in an area that's new to you, like a library or framework you haven't used before. Recently, Tailwind is something that I have started to tinker with, and yeah, Cursor has been like the best tool that I can use in order to speed the process up. In those cases, it behaves more like a fast reference or a brainstorming partner than a source of truth. Where things start to break down is where context matters most. Business rules, edge cases, and historical decisions are rarely captured fully in a prompt. You can have README files that help cover that part, but it's still a lot more to add into the context. Long-lived systems, especially depending on knowledge that lives outside the code itself, and when the AI output is treated as a final instead of provisional, mistakes tend to settle in and become harder to remove later. Another important area to think about is learning. AI can be very helpful when you already have some grounding and want to move faster, but it doesn't replace the struggle that builds understanding what you're trying to learn. Copying working code feels productive, but if you can explain why and how it works, you are accumulating just a hidden risk. Used well, AI can support learning by explaining and rephrasing. Use it poorly, it can flatten it. Communication is another place where AI quietly shines. Writing documentation, clarifying design decisions, or drafting messages to clients often takes more energy than expected. AI can help translate technical thinking into clearer languages. Even better if you can explain what's the audience that you are writing something to. That doesn't still that will not remove the responsibility for accuracy, but it can reduce the friction of expressing the ideas that are already formed. Maintenance is where the long-term cost of AI generated code becomes visible. Code that no one fully understands is expensive, no matter how it was written. If AI output isn't shaped to match your style, your naming, and your mental models, it will become harder to maintain over time. Consistency matters more than speed once a system has to live for years. Trust is the final piece that's easy to overlook. AI doesn't know when it is wrong, and it doesn't signal uncertainty unless it is prompted carefully. Over time, this can lead to misplaced confidence. A healthy relationship with these models involves a steady level of skepticism, not distrust, but awareness of what it is doing. You stay in charge of what goes into your system, and it will help you with those inputs the best way that you have developed it for. A useful mental model is to think of AI as a junior assistant. It's great at drafting, organizing, and exploring, but it shouldn't be responsible for the final decisions. Another simple rule of thumb is this: if you can't confidently evaluate the output, you probably shouldn't be using the tool for that task. AI works best when rollback is easy and ownership stays clear. There's also a quiet connection here to automation and productivity. AI isn't a system level strategy, it's a local optimization. The real gains come from reducing the friction, shortening feedback loops, and lowering the cognitive load. AI can support all of that as long as it doesn't obscure the responsibility of making or make the system harder to reason about. When it does, complexity increases instead of decreasing it. So, the practical takeaway is fairly simple. AI is already useful for developers, and it can be genuinely enjoyable to work with, as long as its limits are understood. It's a strong tool for drafting, exploration, learning, and communication, but it's not a replacement for understanding, accountability, or the design. In the end, reliable software still comes from choosing carefully what to automate and what to keep explicit. Clarity there tends to pay off for a long time. Thanks for watching.